Okay, you guys have your notes. We're doing day 1. Stoichiometry is the name of the chapter. First thing you definitely need to know is the definition for the law of conservation of mass, that matter cannot be created nor destroyed, only rearranged. I promise that is on the test. You need to know what the term mole ratio means. So if you were to look at a balanced chemical equation like right here, what I want you to realize is that the mole ratio, like in this case, we have chromium, oxygen, and chromium 3 oxide. This would be a 4:3:2 ratio. Okay? So the mole ratio comes from the coefficients of the balanced reaction. What about here, guys? What would the ratio be for slices of bread to cheese to sandwich?
2 to 3.
Yes, 2 to 3 to 1. Okay, you get the idea. That is the mole ratio. So let's do an example and see what this actually means. And I would like you guys to write these down. I promise they will help you with your homework if you have examples done. I have 100 slices of cheese. How many slices of bread do I need if I want to use all the cheese? Well, in this particular recipe, to make the awesome grilled cheese, it says we need 2 slices of bread. You would have to have 3 slices of cheese, which I personally think is too much. I wouldn't call it awesome. I think that would be too cheesy, but so what? We go with what they tell us. And together, they create 1 grilled cheese sandwich. Okay. Now, this is common sense. Some of you could probably tell me the answer right now because you can relate to this. But let's show how we would show the work for this. So, the given, what is given in this problem? We have 100 slices of cheese. We are looking for slices of bread. So, that's what we're trying to find. Now, for the conversion factor, for today, you could as easily just look at the given and the find and look to see what the relationship is in this equation. Okay, so what is the relationship between the slices of cheese and the bread? Exactly, okay? So, for 3 cheese, we have 2 bread. 2 bread. Okay, we're going to fill it in. You have the conversion factor, the solution. You write down what is given. Okay, you want to set it up. Cheese goes on the bottom from the conversion factor. You have the bread on the top. And you know that the cheese will cancel out. You end up with bread. Your final answer should be, okay, so that is how many pieces of bread we would need in order to make our sandwich using that recipe, okay? The next one is a little bit easier because you're dealing with smaller numbers. I have 15 slices of bread. How many grilled cheese sandwiches can be made? Some of you can answer this before I even start to work it out, right? But let's just do it for the sake of getting good at using the formula that they give us, using the balanced equation that they give us. Okay, so what is the given in this next problem? 15 bread. Okay, the find, we're trying to find sandwiches. Okay, the conversion factor, in this case, very good. For every 2 slices of bread, we have 1 grilled cheese sandwich. So, 2 bread equal 1 sandwich. You start off with what was given. What goes on the bottom? 2 bread, 1 sandwich. The breads cancel out. You do the math. And most of you knew this answer to begin with anyway. So it's 7.5 grilled cheese. I should have just put sandwiches, but whatever. Sandwiches. I'll underline sandwiches to emphasize that that's what we were looking for. Does this make sense so far? Okay. If you can just remember, it can be just that easy with moles. Don't let the fact that they're called moles confuse you. It's exactly the same thing. So, when you look at this next example, rather than bread and cheese, we're talking about something else, and instead of the 2-3-1 ratio, now we have 4-3-2. So let's try this next one. Suddenly, you guys see moles and you get scared, but don't. Because look, how many moles of oxygen are needed to react? 6.78 moles of chromium. Now, when you do the conversion factor, you're still using the balanced equation to do it. So, the given is what? Good. Okay. Now, I have one piece of good news that you will like about this chapter. Remember how at one point we had to balance equations? Or I would give you the word equation and you had to write it out? Or I'd give you the formula and you had to write out the word of it? The good news is, for this chapter, we give you all that information, so you don't have to figure it out. If you were in honors class, that would not be the case. In honors, you would have to still know how to do all that stuff, and I would probably be trying to review it, okay? But the first step in any one of these equations is always to balance the equation. I have it written up on the board because it's actually something you need to know, hint, hint. But you guys are never asked to balance the equation first. You know why? If I make you balance the equation, you get it wrong, what's going to happen with the rest of the problem? Okay, so for standard class, we give you the balanced equation to work with every single time. Okay? So we're trying to find moles of oxygen. The conversion factor, if you look at this formula, the relationship between chromium and oxygen, I have for every 4 moles of chromium, there is a total of 3 moles of oxygen. I'm going to put a little 2 there just because it is. Okay, then for the solution, yes?
Why would it be 6? Because there's some...
Oh, good question. Okay, listen. Remember how the bread was? Like the entire piece of bread, the entire piece of cheese? Well, this is the entire compound, whatever it may be. So like for the chromium 3 oxide, even though there's 2 chromium 3 oxygens, we're just looking at the moles. That's the relationship we're concerned with. It's how much of each substance, the amount of the substance, not how many of each particular atom. Okay? So for this stoichiometry, we're just always going to focus on the number of moles, the number in front. Okay? Not a bad question. I'm usually prepared for that one. I usually will answer it before you can ask me. Okay, so let's start with what was given. And the next step, we want to cancel out the chromium. I have 4 moles of chromium for every 3 moles of oxygen. You do the math, and your answer should be 5.09 moles of O2. I'm not going to wait for you guys to punch it into the calculator because this is the easy stuff. If it was scientific notation, maybe we would have checked it. Okay, moving on. By the way, I had some students who finished their homework within 10 minutes today. So if you really didn't want to have chemistry homework, you could easily do that. Okay, next one, last example. And you'll do all of the homework exactly in this manner. How many moles of chromium 3 oxide can be produced from 9.55 moles of oxygen? By the way, you see how it's called chromium 3 oxide? I'm not going to review it again, but overall, it's an ionic bond with a transition metal, and that is why the Roman numeral is there. That's why it's called chromium 3. But you know what? That was another chapter, and I don't really want to go back to it. Now you're just going to take my word for it and just keep moving forward if you forgot how to name them. Okay? So, given is what? 9.55 moles of oxygen. We're trying to find the moles of chromium 3 oxide. The conversion factor is what is the relationship between oxygen and chromium 3 oxide? 3 to what? 2. Okay, so for every 3 moles of O2, it is equal to 2 moles. Okay, I feel like I have to do something real fast. Those who care. The reason it's called chromium 3 oxide. Remember this, oxygen has a -2 charge, but there's 3 of them, so together this is -6. The chromium would have to be equal but opposite, which is a +6. There's 2 of them that make that +6 charge, so that's where the 3 comes from. Each one of these has a +3 charge. That's why we call it +3. But I don't really want to go back to all that again. Okay, start off with what was given. What goes on the bottom? 3 moles of O2. The 2 moles of chromium 3 oxide goes on top. The moles of oxygen cancel. You do the math, and you should end up with 6.37 moles of the chromium 3 oxide. Okay? Guys, for the homework, you do it exactly the same way. Do not focus on any of the subscripts. Just look at the coefficients, the numbers in front. Now, for your homework for tonight, those that did not have a balanced equation, I already balanced it for you. So all you have to do is plug in the ratio for the conversion factor, then you solve. The homework is pretty straightforward. I don't think I've had a question all day. I've had so much free time to get my stuff done. But if you guys have questions, let me know. But it's that day 1 homework on the right side. Oh, right side. Due Thursday. Oh, you guys get extra time too. Yes. Yes.
Can we just do the solution?
You're supposed to do the give and find, whatever. Oh, wait. This is why. Listen, you do show your work on a separate sheet of paper, but this is what I want to tell you. This test is different than any other that I have given you in the sense that it's got more free response questions that are worth a lot of points. The free response make up like 40% of the grade, and the multiple choice makes up 60%. Meaning you have to know how to show me work because you literally get a point for every step that you show. We're going to get in the habit of doing that from day 1. Okay, guys? So let me know if you have any questions. You know what? I forgot that there were times in the past I would give the answers. I think I'm going to do that. I should have done that for my other classes. They're going to be mad at me now. If you guys want the answers and you want a clear copy of it, you can come take a picture. But like I said, to get credit, you show step by step all of the work. This whole chapter, if you guys ask me for the answers, I'm very likely to give them to you.
That's the only page?
Yes.
Jonathan, can you ever put up a quiz link for English?
Can I get it real fast and then let everyone else?
Can I get my binder from my locker?
Sure. Yep.
Why she posted twice? She posted 2 quizzes on this month. Virgin of Venice vocabulary quiz Wednesday, March 8th. First quiz